So let's talk about some of the learning objectives. So basically, if you go on to the next screen, Giulio, some of the things that we're going to be discussing today are basically going into the intro of Defender for Cloud. We're going to understand the difference between depth and breadth protection. And then we are going to go into, well, Giulio is going to go into understanding Defender for Azure Resource Manager. And afterwards, he's going to talk about how to automate responses specifically using logic apps. We're going to give you a demo, and then I'm going to talk about Defender for DNS. And finally, I'm also going to give you a demo focused on Defender for DNS, but we're also going to show you some automations that you can use both for Defender for DNS and for Azure Resource Manager. Okay, so if you go on to the next slide. So now we're going to talk about what is Defender for Cloud. So basically, Defender for Cloud is a solution for cloud security posture management, which is CSPM, and also cloud workload protection that helps you to find weak spots across your cloud configuration and helps to strengthen the overall security posture of your environment. And it does that using several things like KPIs such as secure score and also regulatory compliance as well. And it can protect workloads that are across multi-cloud and hybrid environments from evolving threats. So it integrates with a range of products to enable seamless response and automation for your SecOps teams as well. So if you go on to the next slide. Okay, so now I want to give you an overview of the full stack of coverage of workloads that can be protected using Defender for Cloud. So we have protections in Azure, such as starting with protecting your compute workloads, app services, Kubernetes. You can also protect your databases and storage. And actually, next week, I've got a presentation that will be dealing with specifically on protecting your databases. So I recommend watching that on Thursday next week. And then, of course, you can also protect the Azure service layer, which we will be talking about in detail today. And then last but definitely not least, it's not just Azure that's covered. We can also protect your AWS and GCP workloads with our new super easy to deploy connectors. And you can also protect your on-premises workloads using Azure Arc. Okay, so if you go on to the next slide there, Giulio. Great. So now we're going to talk about the difference between depth and breadth protection. So this can be split up. Our basically Defender for Cloud offering includes these two types of security solutions to protect your cloud workloads. So the first type offers tailor-made cloud depth threat protection for the most popular workloads, for example, virtual machines, web applications, containers, databases, and so on. And this kind of depth protection, going into detail, is based on the knowledge of the inner workings of each one of the workloads. And the second type of protection that we have is the native breadth threat protection for every workload in Azure, and it's based on the Azure service layers, such as based on Azure DNS, Azure Resource Manager, and Azure Key Vault as well. So this breadth protection is designed around core Azure services that interact with all Azure resources. So, for example, Azure Resource Manager interacts with lots of other things in Azure as well. So if we go on to the next section, cool. Okay, so now I'm going to talk about how you can actually turn on this Azure breadth threat protection. So first of all, the way to turn it on is it's super easy. You just go into environment settings and turn on the specific plans. And these can be Defender for DNS, Defender for Resource Manager, which are the two we'll be discussing in detail. And there's also Defender for Key Vault as well. And this basically helps you to protect all workloads that are connected to Azure and gives you a detection of complex cross-workload attacks as well. And the service layer is this service layer protection is based on services that act as gateways. So if you think about the Azure Resource Manager, that acts as a gateway too. So all Azure resources are managed through the Azure Resource Manager. It provides a management layer that enables you to basically create, update, delete resources in your Azure account, so do the CRUD operations. And Defender for Azure Resource Manager can track these workload actions and determine which of these are likely to be suspicious. And then we also have on the other side, we've got the domain name services, which also acts as a gateway. So domain name resolution for Azure resources is performed by the Azure DNS infrastructure. And Defender for DNS monitors these DNS queries, and then it determines if any of these queries are suspicious. So by monitoring both channels of communication with the world, it's possible to protect all your Azure workloads from cybersecurity threats, even the workloads that you do not have the Defender plans enabled. And if we go on into the next section. Okay, so now let's talk about an application example. So we have a simple web application composed of a web server, database, and file storage. And if you just press enter, Giulio, now I'm going to show you how this application can be implemented within Azure. So we've got an Azure virtual machine that is basically letting you act as a web server. We've got Azure SQL that can be used as the database. We've got Azure Blob Storage as file storage, Key Vault, which is used to securely store the secrets used to access both the SQL Server and the Azure storage. And last but not least, we've got the Azure Firewall, which is able to limit incoming and outgoing internet communication over HTTPS to the web app itself. And if we go on to the next one, great. Okay, so for this one, basically now I'm going to show you how you can, an example of a possible attack sequence and see how Azure Native Breath Protection can help us to identify and prevent such attacks. So if you just press enter, Giulio, great. So we have an attacker who is interested in looking at the web application, trying to get access to our secrets, and it's actually all ultimately for the aim of being able to get access to our data. So very first thing, we have, so in this example, the attacker is performing the attack from the Tor anonymizing network, and then starting with initial access. The initial access can actually begin when the attacker, for example, manages to acquire some kind of leaked credential from a leaked database, for example, or even from a phishing attack. And this action will lead to an alert that's listed out there, and that comes from Defender for ARM. And then next up, when the attacker tries to access Key Vault and get a hold of the secrets, which are used to access the SQL database and the Azure storage, using that, then the attacker will try to access the SQL servers and then also leverage Azure DNS to send this data back into Tor via DNS tunneling as well. So if we go on to the next slide. Great. So that was an introduction on Defender for Cloud and also on the benefits of breadth versus depth protection. And next up, I'm going to hand it over to Giulio.
Thank you, Liana, and thanks so much. Excellent work on the introduction and really great job on walking us through the hypothetical attack, which indeed it is an hypothetical, but very much likely a real true attack. So what we're going to talk now, sorry, my keyboard is not, okay. So what we're gonna cover right now is the very first plan out of these sessions, which is basically the Defender for Azure Resource Manager. So what is Azure Resource Manager? Liana briefly described what is a Resource Manager a couple minutes ago, but basically to reiterate what Liana said, the Azure Resource Manager, also known as ARM, it's used as an acronym, is the deployment and the management service for Azure, which will provide the entire management layer, which will enable you, the customer, to create, update, and delete resources within an Azure account. It can be leveraged, just like you see from this picture, through Azure portal by basically accessing the GUI version of the management layer. It can be accessed programmatically via PowerShell, via Azure CLI. It can be also programmatically be interact using REST clients, and all this basically through SDKs go into the management layer. Now, this is a very crucial component of the Azure, as we described. Therefore, it is very important to protect it. On the previous example attack, the very first step was basically the malicious persona, the attacker, which through a Tor anonymous network gained anonymous access on a VM. That first step was actually detected by the Defender for Azure Resource Manager. So how we actually go ahead and protect your breadth of Azure resources? Well, what we do behind the scene is once we enable the plan for the resource manager, we'll start collecting telemetry data that are generated by the API calls made to the ARM, to the resource manager. All those calls are also called operations. So we collect and monitor such data, and we start basically executing detection rules or sets of machine learning, which will then generate an event, therefore will trigger an alert and incident. By doing so, we are able to protect all your Azure workloads against exploits in the resource management layer, as well protect against credential theft, permission abuse, and malicious insiders. And actually, the second bullet right there is going to be demoed in through my demo. So here are some example of what we're able to detect. There is also an hyperlink under the full list of alerts. If you just click it on, it will take you to our documentation where we have the reference of all the Defender plan alerts. Within that documentation, there's a sections for resource manager. We have around 37-ish, I believe, or 38 different alerts based on different detections. Okay. Here, however, we laid out a couple of those examples. Okay. Number one, we detect suspicious high privilege management activity, such as if you are a malicious persona and you gain access and you breach some sort of like identity, whichever identity is, then you can use that identity to generate and elevate privilege for yourself or other resources. That can be detected. We can also identify the usage of malicious Azure exploit toolkits such as Microburst or PowerShell. Microburst and PowerShell as well as Azure Write, those are basically open source tools that were originally developed for research objective. The purpose was to basically prove out that Azure or similar cloud like AWS as well can be exploited through their vulnerabilities. However, as any other tool out there, which was developed for a benign purpose, there are also malicious people, malicious groups that are utilized and weaponize those tools. Microburst and PowerShell are actually very popular into those groups. They are used for pen testing, also for reconnaissance and exploiting all kinds of vulnerability. They are available through Azure and the Azure Active Directory. As a matter of fact, the demo that I'm going to show you in a couple of minutes is exactly using Microburst to generate an attack and therefore see how we can mitigate the attack by creating an alert and block the attack. Another example is detect suspicious user access. Just like the one in the sample previously that Liana went over, we had a malicious persona coming from a Tor network. Well, we can manage that anomaly. We can detect that anomaly. Therefore, we can very easily create and generate the alert, even if it's a Tor network or if it's a known botnet. As any other security stack and security tools in Azure, we are automatically integrated within our own Microsoft Mystic threat intelligence. Therefore, we know exactly on a daily basis what are the most known botnet IP addresses networks. So therefore, our tool is capable to, almost in real time, as something comes up from a suspicious source IP address, known if it's a botnet or even if it's a Tor network. Therefore, we're able to alert you. Also, we can very easily detect any suspicious management sessions. They're done through either the portal or through PowerShell. Now, once you get the plan as a detect an anomaly, generates that event, and therefore generates an alert, the next thing that's going to happen is, okay, I need to investigate in such alert. However, for some types of alert, it is very valuable that you are going to automatically execute a task, an action that will stop the actual compromise attempt, all right, or the attack. How do you do that? Well, basically, Defender for Cloud has a feature called the workflow automations. Workflow automation allows you to create a set of automatic actions based on specific rule. And those actions can be triggered either by a security alert that has been generated, or based on new sets of recommendations, or any regulatory compliance status change. So we have those three pretty much ways that you can automatically trigger that workflow based on the rule, and therefore the automation that is being configured with the workflow will execute and do whichever has to be done. The automation at the end of the day is executed through a Logic Apps, which is a microservice a resource in Azure that you can utilize to build this workflow. To build the workflow, you're basically assembling components. Those are basically connectors. Logic Apps has an extensible list of native connectors, either Microsoft connectors or third-party services connectors. If you don't really see a connector that is suitable to your need, to your use case, you can still build a custom connector, or you can easily leverage a regular HTTP GET or HTTP POST or HTTP patch, whichever is the need that you have to do it, in order to invoke the REST API. And just like a regular REST API call, you can do much of those actions. So now what we're going to do, actually, I'm sorry, this is a picture of an automation workflow, a Logic Apps that we as a team built in order to mitigate an attack where a user account, an identity within Azure Active Directory has been breached and has been utilized through either the identity itself or through its token, the bearer token, and it's being utilized for an attack. This actually playbook is available under our GitHub repository. There is a link underneath that will take you to a blog post that explains the actual the automation, and then also link to the GitHub where you can download it, or you can basically easily click on deploy and then import into your environment. Let's move on right now on the demo. So for the demo, I'm just gonna gonna change screen for a second. Okay, so I just zoom out a little bit, therefore you might have a better view. But what we are right now, we are in the Azure portal. We are at the Microsoft Defender for Cloud. As Liana initially described, you need to enable those planes, which are by default disabled. How do you enable? Is through the environment settings. So you go under the management section of the menu, click on the environment settings. Now, here you're going to have a list of all the environment that Defender for Cloud is managing, perhaps Azure, but you can also have such, AWS account or GCP. In our case, we'll look into Azure. The first thing you're going to see is the management group. So you have to expand your management group until you actually get to your subscription. You click on the subscription that you wish to initiate the plan, and then under the Defender plan, you have the list of all the plans that are available to be turned on or turned off. By default, they're all turned off except for the secure posture management, which is free and is automatically included. However, you need to turn it on and save it. In this subscription, I have the Resource Manager turned on already, but I do not have the DNS turned on. Therefore, what I'm going to do is click it on and then save it. By saving, right now, the plan is on. It's going to go ahead and acknowledge the protection, and it's going to do its magic in order to protect the workloads and as well as generate the alerts. Once the plan is on, now it's ready to monitor and it's ready to generate those alerts. In this demo, I actually use microburst to generate a very simple attack. It's a simple but very powerful. That attack that I simulated is based on the notion of I gain access of an identity, a user account, or actually a credential, not directly to the full credential as a username or password, but I was able to compromise a regular workstations, and through their workstation being the having access of that workstation, I was able to extract the VR token, the authentication of VR token of a user account that had an open sessions with the portal, with the actual resource manager. For those of you that don't know exactly what is an authentication VR token, that is an access token that contains the claims that you can use in Active Directory to identify the granted permission to an API. If an attacker is able to retrieve this token, it can use that token to emulate the user account, even without having the actual password. Therefore, you are now pretty much emulating exactly the user account and permissions. So what I did, I used microburst to execute a command, a PowerShell command against Azure, so I can exploit. First of all, I can do a reconnaissance, and then I can exploit the storage accounts in order to extract keys for further lateral access to content. The way I did, again, I used this toolkit with the token that I stole from a live authentication. When that happened, the Microsoft plan, the ARM Defender plan detected the actual activity as the operation has been executed by the ARM engine, and then automatically generate those sets of alerts. If you click on the actual alert, you can read the description, and the description will show exactly what I did. It's a PowerShell script that was running your subscription and then performed a suspicious pattern of extracting keys to storage accounts. It is also labeled as a collection tactic, indeed, because I'm now doing some reconnaissance and I'm trying to collect as much as data information to now then initiate either persistence or moving laterally tactics. If I click on view in detail, at this point, I have accessibility to more information about this specific attack. First of all, I can see that it is executed by the IP address 73.133.37.163. The user account that has been, let's say, breached, that's being utilized and leveraged is Megan B at this domain name. There is also the user ID number has exposed in the Azure Active Directory. It is a PowerShell command called get AZ storage key rest for microburst. The entities attached are indeed the account, the resources that were part of the exploitation, the storage accounts, Again, the IP address and the network are pretty much the same. So here I have a couple of things I can do. Number one, I'm going to go to Take an Actions, and I can start my investigation by simply click Open Logs and then further look into details, into the details that were recorded during the actual monitoring. If I open up the record, I have plenty details over here that I can now leveraging for as a body of evidence for my investigation. Second thing here, now I want to go ahead and stop the actual attack. All right. What I need to do is obviously I want to disable the users. I want to disable those live sessions. So I want to revoke all those tokens. Now, can I do that manually? Of course I can, obviously. However, maybe I am not the type of a resource with the proper permissions. I'm a SOC analyst, maybe like the security help desk level 1, level 2, whichever is that is now triaging this alert. I don't have the proper permission in Azure Active Directory. I don't have a permission in Azure subscription. I don't have this permission Active Directory to revoke the tokens and as well as disable the user. Therefore, the only thing I can do is I can either escalate the alert, someone that has a proper the proper permissions, or but it's going to be maybe too late, or maybe I can use my logic apps. Now I can also add that a workflow that automatically does the disablement as the alert has been generated. But here, for just for the sake of the example, I can now manually trigger a logic apps. Once I trigger these logic apps, the logic apps will run within the security, within its own security context. So if the logic apps has been configured with the proper permission to do an actions, then it doesn't matter who executes it, he's going to do whatever has to do it. In this case, we look into this MDFCs, disable the user account logic apps. So I can easily select it and trigger. Once it's triggered, now the execution is handed over to the logic app stack, and I'm going to show over here. And then basically, as you can see, right now, that logic app has successfully executed and then has disabled the account. So if I'm going to the user Active Directory list, and on the Active Directory user list, I can see that Megan Bowen now, hopefully, it takes a minute, should be disabled. Hold on a second. Okay, it's disabled. It's just time to refresh. So now this account has been disabled. Also, if I'm going into my email box, my inbox for my email, I should received a new email that is now telling that Megan Bowen, marketing manager, has been disabled due to a detected suspicious activity using a leverage data account. Okay, how that was done? Very simple. So if you go back into the logic apps, and we're gonna have it. What we can see is that there is the connector that is triggered by an alert. So if we have this trigger and we automated the actual action, we don't have to do that manually. Automatic will execute it when the alert is being raised. We actually did it manually. However, the first thing it's going to do is going to trigger these logic apps, and it's going to go ahead and iterate through each entities that are attached to this alert. We have different entities. Only one I'm interested to is the account. Therefore, if the entity is an account, what it's going to do is going to get the user using a regular HTTP GET to the Azure Resource Graph, and then once you get to the user, and he's going to go ahead and refresh the token, so it's going to revoke all the token. Therefore, any live sessions that a user has with any browser or any like a programming tool that she actually authenticated against the REST API of the ARM will then basically disable, will basically revoke. So those sessions will be dead. After that, you're going to disable the users. And then obviously the rest of the playbook over here, so the logic apps, is simply try and get like information about who to email the notification. I mean, in this case, I was notified because I'm listed as a manager of the resource. If you look the property, the property of the resource, I'm the manager. Therefore, the logic apps picks up the information about the manager over here and sends a notification to the manager. If there is no manager, it will send a notification to an account that you set as a default. So now I have done two things. Number one, I have full information about this attack. I have a full data for the investigation. And two, I actually stopped the bleeding. I blocked the user account. Therefore, the malicious attacker, the one on the example, is no longer a way to exploit those resources, the storage account, through the actual user account. But so we're done with the demo. Therefore, I'm going to.
Great.
Yeah, I'm gonna hand back over to Liana, and Liana, it's your turn right now to cover
Thank
Defender
you so much.
Go ahead.
Thank you for Defender for DNS. Yeah, thank you so much. I will actually take over now because I've also got a demo. So you can just let me know now when you can see my screen. Great.
Yep, we can see it.
Awesome. Okay, so now we're going to talk about Defender for DNS. And actually, before we do that, let's start by first understanding how Azure DNS actually works, and then we can understand how it's used by attackers in a typical Azure environment. So, when an Azure resource tries to access an external host by using a domain name, this domain name must actually first be translated into an IP address. And it's the Azure DNS infrastructure that's the part that actually does that. And in our example, we have a malware-infected virtual machine. And this malware is trying to connect to its command and control server. And it's going to do that by using a DNS request to figure out what's the IP address of the command and control server. And it's Azure DNS that will receive the request and then send the response back with the specific IP address to the command and control server. And what we do is that by monitoring DNS queries and responses that are performed by Azure Resources, then Defender for DNS can detect the communication that is with malicious domains from your Azure environments, but it can also protect your Azure workloads against exploits in the DNS layer. Okay. So now let's look at the types of detection examples that we have. So we group them for Defender for DNS into two main buckets. So we've got detect communication with malicious domains, and these are basically communications with things like suspicious domains, domains that are associated with these known command and control servers that I've listed out in a few examples, with botnets, with threat actors, but also domain names that are associated with other things like Bitcoin mining, phishing, and the dark web. And the other bucket that we have for Defender for DNS is detect exploitation of the Azure DNS layer. So we can have DNS tunneling, which is exfiltrating data through these DNS queries. We can also detect these signatures through the network intrusion signature piece of botnets, malwares, Trojans. There's DNS cache poisoning, which actually changes the DNS response, which basically brings these users to either the attacker's domain or to a domain that wasn't intended. And then there's also sinkhole DNS as well. So these are some of the detection examples that are part of Defender for DNS. And what actually happens is that when those detections are triggered, they can be seen in Defender for Cloud as alerts. And here we have some of the examples of what the alerts, some of the example alerts that are part of Defender for DNS. And they're all correlated to the detection examples that I told you about previously. So you can see attempted communication with suspicious sinkhole domain, and we're actually going to see that in a minute in the demo, communication with possible phishing domain, and so on. Okay, so in the demo, I'm also going to show you how you can actually validate some of these alerts for yourself, and it's super easy. It was an article that was originally written by Yuri Diogenes, who is my manager, and we are going to get these alerts, and then afterwards, the next step that we're going to do is we're actually going to block the suspicious activity from happening. So we've got this logic app, and this is another logic app that I'm going to be showing you. It's basically helping you to automatically block these outgoing DNS queries, especially if these queries were actually going to malicious domains. And the way that it does this is by, in the virtual machine, it actually gets the NSG, which is a network security group associated with the virtual machine, and it adds a new rule. It creates a new rule in the NSG to block that outgoing traffic from happening. And it can do that by blocking traffic to the specific IP address that the query was trying to go to. So it can block traffic to that specific IP address because we know that from the alert. And I will show you all of this right now in the demo. So let's start by first going into Defender for Cloud and giving you an understanding of these alerts that I called out earlier that are part of Defender for DNS. So I've actually generated all of these, and I will show you now how you can do that. But these are, again, the kinds of alerts that are possible. So we have possible data exfiltration via DNS tunneling, anonymity, network activity, communication with suspicious algorithmically generated domain, and so on. The one that I want to look at now is actually this attempted communication with suspicious sinkhold domain. And so I've just clicked onto it, and now we can see the preview information, but I'm going to go into view full details so we can get more details about this. Okay, so here we are in the alert, and actually Giulio went over a lot of the stuff that is available in the alerts, but you can see that for Azure Resource Manager, the alerts that are associated with Azure Resource Manager and the alerts that are associated with Azure DNS are actually quite similar in what is available. It's just mainly the alert details and the take action tabs that are slightly different, but you have the same kind of overall information up there: alert description, which resources have been affected, and which MITRE attack tactics is involved here. And this one is exfiltration. So for the alert details, we can see the domain name that we were trying to go to. We can see the IP address as well, and then we can get some more information about DNS and the host. And then also we can see that we do have the IP address just listed out specifically, and this is actually a key requirement of our logic app. But okay, let me show you how you can actually generate this this alert, as well as some of the others that we called out that I showed you earlier. So in order for us to do this, we actually need to go into the virtual machine. So we need to connect to the virtual machine, and we need to run these commands. So I'm just going to get the commands first, and you can do that from this page that I called out earlier. And you can see we've got the commands here, but I'm actually going to take the queries underneath from these because it's faster for the demo, so either works. And now I'm going to open up the virtual machine. So I already have it open for this demo. And in the virtual machine, we just need to open up PowerShell, and then basically just paste this, press enter, and that's it. So in this case, we already have Defender for DNS turned on. That's kind of an assumption that we've already got the plan turned on in the environment settings, as Giulio showed earlier. But because we do have the plan turned on, what will happen is that in just a few minutes, the alerts will appear that are associated with these queries. And actually, you'll see, for example, that because it's the same query that I used earlier to generate the last alert, you can actually see the IP address as well listed out over here. And what we're now going to do, so what we've just done is we kind of put on our our attacker hat and try to do these kind of attack ourselves in this case, you know, just for the demo. But what we're now going to do is we're actually going to change hats, and we're going to become SOC engineers to try to basically stop this attack from happening. And to do that, we are going to go back into our alert. Okay, so once again, this is the attempted communication with suspicious sinkhole domain, and we've got this IP address here. So what we want to do now is basically we want to block this IP address we want to block the attacker from going to this IP address. So we need to go into take action, and we need to go into the trigger automated response. And we're going to trigger the logic app. Okay, so while that's loading, basically I can show you that I have actually already installed the logic app, and I've done this from this GitHub page. So maybe Ashley or Valon, if you can share out the link for this one in the chat window. So this is the GitHub link for how you can get access to the logic app and how you can actually deploy it in your own environment as well. So I've already gone through this process, super simple, and now I can basically utilize the logic app for this. So I'm going to be manually triggering it from here, but you are able to set up a workflow automation, as Giulio called out earlier. Also, you're able to set up that workflow automation so that when the alert kicks in, you can just have the logic app trigger by itself without having to click this. But for now, we're going to click it. So we see this block suspicious DNS activity. That is the name. That is the name of this logic app that I've given. So we are going to basically tick it, trigger it, and that's it. So let's actually see what happens in the logic app and the result of what will happen as well. So now we have this logic app here. So how it works is, first of all, it's waiting for this when an Azure Security Center alert is created or triggered. We've done that. Like I said, we have triggered it. And what it now actually does, these are all lots of variables that it's initializing, and it's now parsing the JSON of the alert. So the JSON of this alert. And it's getting information from that. So next up, it's actually going to get the Azure virtual machine, because this is through a HTTP GET request. And we need this information because we actually want to get to the NSG, the network security group associated with this Azure virtual machine, in order to block the attack. So we get the Azure virtual machine here, and then from that, we're able to get the NIC. And from that, we are able to get the NSG rules that we have. And we're going to actually go into this loop to see what the next available rule priority is. The rule priority is starting with 100, and you can't have, especially for like outgoing or incoming, you can't have the same rule priority twice. So if there's already one of 100, 101, 102, it'll select the next available one. And then in this HTTP request, it's actually a put request, and it will basically put in the attacker IPs to deny the outbound traffic to that attacker IP. And then afterwards, it'll send an email about this. So if we actually see what this looks like in the virtual machine itself, so you can get an idea. So say we are now in our virtual machine and there. And we need to go into the networking tab. So here I am in the networking tab. There's inbound port rules, but that wasn't what we were interested in, because we were trying to stop this outbound traffic from happening. So you can see that in our case, it was actually this one, the 101 block outgoing traffic. And it was blocking traffic to this destination IP address. It was a deny rule. And just to prove that this is associated with what we did there, so let's go back here in the alert details, and you can see the IP address in there. You can see the that we have actually blocked this IP address. We've blocked anyone in our virtual machine from going to this IP address. So we've essentially super quickly put have this have the attacker be blocked from trying to do what they were trying to do. So this is basically talking about the how you can block these attacks, especially these these DNS attacks from happening. So yeah, I guess if we go back to sort of summarize what we have gone over. So overall, what you have heard today in today's session is you have gotten an overview into what Microsoft Defender for Cloud does. And then we talked about the difference between the breadth protection and the depth protection. Remember, the depth protection is associated with specific workloads, whereas the breadth protection is associated with protecting several workloads from one Defender plan, say, for example, Defender for Azure Resource Manager. And then afterwards, Giulio went in detail about the Defender for Azure Resource Manager plan and talked about how Azure Resource Manager works. And then he also showed a logic app. And first of all, talked about how logic apps work and showed a logic app for helping to basically stop these attacks in one example. And then that was Azure Resource Manager. And then we talked about Defender for DNS. So I showed you what it is, how it works. And then also I demoed a logic app as well, how to block an attack, and showed you how to actually simulate the alerts as well. So yeah, that concludes the presentation. We have a lot of resources that you can use, so we can share these out in the chat window with yourselves. And yeah, thank you so much. And if there's any questions that haven't already been answered.
Yes, we do have quite a few questions here. Let's see.
Cool.
Okay, so the first question is, which Defender plan should be used to protect Azure Synapse?
Okay.
I don't think at the current time we have a plan to protect the Azure Synapse vertically. So when you look into the depth and the breadth, the depth goes into each individual resource within the Azure, such as a VM. One of those resources will then be the Azure Synapse. At the current moment, we don't have a plan available.
But Giulio, just so actually our Microsoft Defender for SQL, and I just confirmed it there, our Microsoft Defender for SQL does actually cover Azure Synapse Analytics. So Defender for SQL covers Azure SQL Database, Azure SQL Managed Instance, and also Azure Synapse Analytics as well. And then we've also got our open source Defender for Open Source Databases plan, which covers MySQL, PostgreSQL, and MariaDB as well.
Thank you, Liana.
No problem.
My bad.
No worries, no worries.
Thank you. And the next question, if we have Microsoft Defender for Endpoint, will Microsoft Defender for DNS still be required, as the EP solution should take care of the CNC type requests? Yes?
Okay, so basically these are two separate plans, and they are based on different detection mechanisms. So there is still benefits for having Defender for DNS as well. And as well as that, it's not just the command and control type of detections. Like I called out, there's several other things as well that Defender for DNS can alert.
Okay, thank you. And how can we suppress a vulnerability scan report false positive?
So this is for vulnerability assessment. Okay, so and I actually received this question very recently as well. So basically, if you, for example, want to check what vulnerabilities are in your environment, you can do that from, we do have recommendations that are available for this. So what you can actually do is in the recommendation, you can actually choose to disable certain aspects of the vulnerability. So if there are any vulnerabilities that you are not interested in seeing, you are able to disable, you're actually able to disable those from the recommendation, from the vulnerability recommendation itself.
Okay, thank you, Liana. We have answered all of the questions, so thank you, Liana and Giulio, for being our guests today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. At the same time, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/securitycommunity. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We love to hear your feedback on how we can improve these webinars. Please take a minute submitting your feedback at aka.ms/securityWebinarFeedback. Thank you and see you next time. Goodbye.
Thank you so much, everyone, for joining. I hope it was helpful.